Hey guys, this video is in response to PatrickJMT's challenge to solve this equation. And so let's get to it. So first of all, we should take this 3 to the nth and bring it to the numerator. So let me write out this expression again. N equals 0, and everything remains constant, except for it's going to have a 1 over 3 to the nth. I guess I'm bringing this to the numerator, or not really bringing it to the numerator, but just putting it on there, putting that expression on it, and it will have a constant 2n plus 1. Okay, next what we have to do is we have to bring this square root of 3 inside this equation. And what we want to do is bring it as a fraction, so it's onto the denominator, kind of in the same form of this, except for it'll be square root of 3. So let's do that. So now it'll just be 2 on the outside, because we're bringing this in. Sigmas, and so negative 1 to the nth. And again, we'll have this 1 over 3 to the nth. And now we will also have a 1 over square root of 3 to the negative first. Because if we do the negative first of square root of 3, it'll just equal square root of 3. And since there's no variable in there, we can just bring it out there. So basically, we just took this and put it inside the expression. And we'll have the same denominator. So what we want to do now is separate this term into something that looks kind of like this 1 over square root of 3. And the way we do that is we turn it into two terms. Square and the negative 1 to the n will remain the same, but this will be in this form. Okay, so the square root of 3 to the negative 1 remains constant, but these came from this. Basically, I split it into 2. So if you multiply these 2 together, you'll just get 1 over 3 to the n, and that's why we could split this into these 2. Okay, so next, since these all have the same common inside, then we can multiply them all together. So again, let's write out this expression, but more simplified. So most things remain the same. So for now, this is going to be 1 over square root of 3 to n minus 1 over 2n plus 1. And as you can see, this since these are all the same inside, like I said, you can just multiply them all together. And when you multiply things with squares or things to the square root, you just add them together. So this will just be n plus negative 1, which will just equal 2n minus 1. So what we do from there is we multiply this expression by 1, but 1 in the form of 1 over square root of 3 over 2 over 1 over square root of 3 to the 2. So make sure you realize why this is 1. And in math, we know that you can always multiply anything by 1 and it doesn't change anything. So since we have this here, the square root of 1, we can just put this. Well, let's first look at this one. We'll just, since it'll be constant, we'll just move it all the way outside the bounds right here. So on the inside, it'll just be 2 over 1 over square root of 3 squared. And we'll have our sigma and our bounds again. And negative 1 to the n will remain constant. But now, once again, remember that they have the same insides, so we can just add these 2 together. So, or multiply these 2 together, but add the exponents together. So this will be 1 over square root of 3 to the 2n plus 1, because 2n minus 1 plus 2 equals 2n plus 1. And the denominator will be kept the same once again. So now we have an equation that looks like this. We're going to use our Mclaurin series rules, and really the only Mclaurin series one, well, not really, but one that looks most like this is this equation right here. If you want to look up all the Mclaurin series, you can just type it in online, but this one looks like the most common. As we can see, we have the negative 1 to the n, just like that, the bounds, same. It doesn't matter, these don't matter because these are on the outside of it and they're just remain constant. The 2n plus 1, just like in this, 2n plus 1, and an x value to the 2n plus 1. So basically this whole inside here, let me do this with a different color. This whole inside here can be replaced with tan x. So we can just rewrite this expression as 2 over 1 over the square root of 1 over 3, or I mean 1 over square root of 3 squared times tan to the negative 1 times 1 over square root of 3. We can rewrite it as that. And the reason this x is 1 over 3 is because in this, the x is this 1 over square root of 3, just like in this. So naturally we just replace these two. So if we get this equation, we can see that we can just multiply this all out real quick. So 2, and then the square root of 1 over 3 is going to be 1 over square root of 3 is going to be 1 over 3. And when you multiply this all out, that'll equal 6. So our outside will be 6. And our inside, arctan of 1 over square root of 3 equals pi over 6. So this will equal pi over 6. So we multiply them together, just like in these. 6 times pi over 6. These 6's cancel out, and our answer will be pi. And that's how you solve that equation. I hope you enjoyed and were enriched by this video, and I'll see you in the next video.